Hello there, and thanks for tuning in to Manipulating with Logs. We're going to go over a couple of the properties first that you should familiarize yourself with. Just like exponents, logarithms have these properties and patterns that you can predict, and math teachers are meant to kind of help you manipulate them so that you can use the rules but bend them to your will. A couple of the ones that that first I would, okay, let's go with highlighter there. This first one is just like a truth about logs and exponents. The log of one base anything is 0 because b raised, that base raised to the 0 power is 1. Same kind of theme. What power does b have to be raised by to get b? Answer is 1. That's just a truth about logarithms. The third one is another like a little easy puzzle. What does b have to be raised by to get b to the k? Answer is k. Okay, now this fourth one, I'm not exactly sure what the property of it is, but I would call it the inverse property because this one it's a b raised to a log power. So because exponentiation and logarithms are inverses of each other, this really kind of cancels out the functions, and what's left is just what we call the argument, x. Okay, we're going to come back to number 5. We have done what's called, and it'd be good to just write these down, the product property of logs, the power property of logs. Number 8 is the reciprocal property of logs. And then number 9 is the quotient property of logs. So when you have the log of a product or the log of a number to a power, the log of a number to the -1 power, something happens. And then if you have a quotient or like a fraction, the log of those. Now, number 5 is kind of a combo of the product and the power. And so it is just breaking up b to the k and x, and then taking the power out in front, and I think that is it's also a combination of number 3. So, okay, so here's some of the things that you should, to be able to kind of manipulate with logs. I just made up some examples where we talk about condensing and then expanding, because sometimes, just like equations, things are going to get big and then you need to combine like terms and get them smaller again and condense them. And sometimes it's good to expand them so that you can kind of break them apart and take them piece by piece. Here's an example when it comes to logs. This is a standard terms that it comes to when it comes to the directions. Condense each expression to a single logarithm. 5 log 3 plus log 5 over 2. I'm going to deal with this first expression first. This 5, whenever you see it in front of a log, it can go as the exponent because that's using the kind of the reverse power property. That's going to be log of 3 to the 5th. And then I'm going to rewrite this as 1/2 log 5. And that 1/2 is also a multiplier, so I'm using the power property here that in reverse to make it log of 3 to the 5th plus log of 5 to the 1/2. Or we can write the square root of 5. We can do that also. And now, because this is a sum of logs with the same base, we can write that as one single logarithm, the log of 3 to the 5th times square root of 5. And that's all. Sometimes they're going to be a little more fancy or elaborate or like elegant, but this one you're just writing as a single log, done. Same with this number 2 here, log of x plus log of y plus 2 log of z. I'm going to save a little time and put that 2 as an exponent now with the log of z. So I now have log of x plus log of y plus log of z squared. And this will now adhere to the product property. That means In the example, the property, there's only two things being multiplied times each other, but you can extend that to x times y times z, for example. If you had that, you could say the log of z base b. So this is, in one single log, x times y and z squared. Okay, that was condensing. Here is expanding each logarithm. You're given a logarithm that is in one log, just expand it. This is the log of 3 radical 14, or they have it here as 3 square root of 2 times 7. Those are being produced. So you could say that's 3 times 2 to the 1/2 times 7 to the 1/2. And that is, with the product property, log of 3 plus 2, or log of 2 to the 1/2 plus log of 7 to the 1/2. I've got one more property to kind of use. These square roots, or the exponent signs, can be brought out to the front in the power property. So log 3 stays as it is, but this time I can write 1/2 log 2 plus 1/2 log 7. I have expanded each logarithm. There's no like terms I can add here, because though the bases are the same, the arguments or the numbers there are all different. So though tempting, can't do it. It is not a property. Here's one to expand that is in a quotient. And when you have a quotient property, it is, let's check. If you have the log of a quotient, there's a subtraction sign in between the log of the numerator and the log of the denominator. So this I can expand to be the log base 5 of x to the 6th minus log base 5 of y to the 5th. And now, if I want to expand it to be a log to a single power, that's 6 log x base 5 minus 5 log y base 5. Expanding is a skill just like contracting. All right, final one is where you might have to use, this is a standard like a teacher tool also to kind of manipulate logs, is to use the property of logs and values or facts about logarithms without a calculator to evaluate them. So number 9 here, this example, we're given that the log of 6 base 7 is 0.9, 7 raised to the 1.2 power, around 1.2 power, is 10, and the log of 9 base 7 is 1.1. With that information, or some of that, find the log of 81 base 7. So, log of 81 base 7. Now there might be another way to do it. Maybe, are these red herrings here? Do I need to use the log of 6 and log of 10? Maybe you're seeing something that I don't. I'm seeing the log of base 7. 81 is 9 times 9, or 9 squared. And I'll say that is the log of 9 base 7 plus another one, the log of 9 base 7. Or if you wanted to use 9 squared, that could be 2 times the log of 9 base 7. And now we use our information. You could use the calculator, but they are having you use the clues provided, or the values, that the log of 9 base 7 is 1.1. So that's 1.1 plus 1.1, easy arithmetic, 2.2. Okay, oh, a nice little nugget here. This looks like this is the page number. What is 4 raised to give you 4? This must be, man, is that page number 1? Okay, last one here. Maybe it's time to pause and see if you can't do this one. Given that you've got 3 log facts there, or approximations, find the log of 4/7 base 7. Log of 4 sevenths base 7. This is a quotient property. That's the log of 4 base 7 minus log of 7 base 7. Now, the log of 4 base 7, I don't know that. I'll refer back to the little table here. That is approximately 0.7. Now this one, the log of 7 base 7, what does 7 have to be raised to give you 7? That's just 1. 0.7 minus 1, we're looking at negative 3/10. All right, you will get really comfortable at these properties. Oh, you know what? We're here. Might as well talk about this change of base property. This is if you are trying to evaluate a logarithm function that has a base that you can't use on a calculator or you don't know, you can change the base. For example, maybe I should finish. Change the base so that it's the log of the number on top divided by the log of the base in the bottom. So for example, say you wanted to find the log of 7 base 2. 2 raised to what power is 7? Well, we don't know that. Our calculator doesn't have base 2. We could make it the natural log of 7 over the natural log of 2. I've changed the base. If you in your calculator want to find if you have the common log or the log base 10 of 7 over log base 2, those are equivalent, and they are also equivalent to this number right here. So that's a change of base formula. Hey, if you're still here, you're going to get a nice little treat because I want to show you my puppy Kazoo. Kazoo, do you want to say hi to the Algebra 2B team? Yes. All right. Thank you, everybody.